Good morning here everyone. This video is about a small board that I recently purchased called Teensy4.1 from PJRC. So this video is around this board that I have that I would like to show here, a small demo around this GPIO memory mapped pin mappings that I have that I configured with, and I try to control the GPIOs using memory mapped registers actually. So talking about this board Teensy4.1, it is from PJRC from PJRC group, and it is a series of boards that they have released actually, like Teensy 3.6, 3.2, featuring different processors that come up with it. And after that they have this Teensy 4.0, and now the latest one is Teensy4.1, and this is the Teensy4.1 board that you can see here, and this is the sheet that came up with it actually. So it shows the pin mappings of this board actually, as you can see here. So altogether it's a nice board actually. It has got a lot of features actually. It features ARM Cortex-M7 core with a floating point unit, so that it can support DSP operations. Along with it, it has got 8 serial ports and 18 analog inputs. You must remember 18. It's 18 analog inputs that you can support, so you can connect 18 ADC pins are there, and so you can connect different analog sensors of different kinds with it actually. And of course the voltage needs to be around 3.3 volt compliant actually, so it's not a 5 volt compliant pin board, and it's not CMOS compliant, and it's basically a 3.3 volt compliant pins actually that we have here. And this is the IMX. It features the processor called IMX RT 1062 processor from NXP actually. And this is a small expansion board that I made around it to expose the expansion pins actually of it. And this board also has a USB. It can also act as a USB host as well as a Ethernet controller, which can be used to connect to internet actually, and do IoT stuff actually. So, and along with it, it has got an inbuilt RTC. A hardware RTC is there, so you can control the RTC to control date and time actually. So talking about this small demo that I have made actually, so I have basically exposed and tried to explore the memory mapped GPIO part of this IMX RT 1062 processor actually. So what I have done is that we generally control the GPIOs by driving them high or low, but then there is some way to control them via port based control also, like a input output port. So you have got some port pins, and then if you write them at once actually, like say a string of ones or a string of fives actually, so that should be printed instantly or given out instantly to the output lines actually that are being controlled with a GPIO. And so that's what I have tried to show actually to this GPIO memory mapped registers actually. So what we have here are some memory mapped registers corresponding to GPIOs actually, that I have tried to control it. So instead of controlling them singly actually, what we have tried to do is that we should control them in a parallel actually. So what I have done is that I have connected this small LED circuit board that I have here. So basically each of these LED pins represent bits actually. So these LED pins are going from it's 8-bit LED chip board that I have here. So each pin represents a bit actually. So here the bit goes from D0 to D7, so 8 bits are there, and along with it there's a one ground pin. So what I have done is that here in this IMX RT 1062 processor, it provides this memory map registers. There's this GPIO 7 data register and GPIO 9 data register, DR actually, which you if you check the data sheet of IMX RT 1062, you can find it the data register. So the data register is being controlled here to control the output lines. So basically there are 8-bit is divided into 2 nibbles actually. So the lower 4-bit nibble is mapped to GPIO 7 DR data register, and the upper 4 bits of this one of this say D4 to D7 are mapped to the GPIO 9 registers. There is the GPIO 9 data register. So you have got the data 9 register, in which each bit corresponds to a GPIO position on the GPIO pin that has been correspondingly controlled out here actually. So you have got the register of 32-bit, in which each bit position refers to the pin mapping, or the pin control can be done using those bit positions by manipulating those bit positions in that register, in that 32-bit register called GPIO 7 underscore DR and GPIO 9 underscore DR actually. So if we make that bit high, the pin should go high and the GPIO should go high, and the corresponding LED should glow actually. So this way a very good nice debugging can be done using this LED chip circuit, the LED circuit that I have here. So there is no chip, it's just a LED circuit that I have here. It's just LEDs actually, and there's a pull-up resistors are there, and then they're connected to the GPIO pins, which are being pins, and that can connect to the GPIOs actually. So let's try this demo actually, and let's see actually what happens. Yeah, please wait. Let me switch on the supply, and here I switch on the supply, and here I can see here. Okay, if people can see it. Okay, you can control it. So sorry. Yeah, here you can see here. It is F5. This is FF. This is FF. This is AA. This is 55. This is 5A. This is A5. This is FA. This is 5A. This is FF. This is 5A. This is A5. This is AA, sorry. And this is 5A. This is A5. This is FA. This is 5A. So you can see here the bits are numbered from bit 0 is this one, and bit 8th bit is this one, the last one. So this is about controlling this these GPIOs using memory mapped registers of these which are memory mapped to this IMX RT1062 processor. So this is a very nice processor. There is more to explore the I2S side actually. So it provides this two ports, two I2S and TDM or TDM ports actually, which can be used to control audio actually, as well as quad I2S also can be supported. That's what they have mentioned. So this would be the next thing that I would try here in this with this board actually, Teensy4.1. And I hope you like it, and thanks for watching. Have a nice day. Thank you.